Hi, welcome to Twitter Think. I have a new topic here, differentiating an implicit function. How do we differentiate an implicit function? A function usually in terms of two variables of this form, x and y, giving us a certain function in terms of x or y. It can be a trig function depending on whatever question you meet. Is an implicit function. So there are some steps you need to understand implicit functions to go about them. So I've written some basic steps in my own way to explain for you to understand. So let's go over it. Let me use some few seconds to do that. Now, in implicit function, the first step is apply derivative to both sides of the function. This is what I have here. If I'm able to apply derivative to the left hand and the right hand side, then I'm done with the first step. So you apply derivative to the left hand side and the right hand side. Whether this side is 0 or not, just apply the derivative. Then the next step is use the derivative to multiply each term one by one. So now the derivative I applied here, usually the left hand side of the function will contain multiple functions. So you use this one to multiply the derivative to multiply each term, the first term, the second term, the third term. Then differentiate each term accordingly, one by one. So I will differentiate each term accordingly. And then factorize dy dx by grouping all functions containing dy dx to the left hand side of the equation. So now, by the end of the day, you realize that some functions, after you differentiate the functions, there will be some functions that will be in terms of dy dx. These are functions you differentiated according to y with respect to what? X. So for these functions, you group them to one side of the equation. Usually you group all the functions to the what? To the left hand side, and you equate the function to 0. So that is what the final step is saying. Make sure you equate the function to 0. So these are the steps that you go through to solve implicit functions. So I'll take this example, and I'm sure by the end of the day you'll get the concept. So the first rule says that apply derivative to both sides of the function. So I'll apply derivative. Now remember, we are differentiating all the function with respect to x. So I have x raised to the power 3 plus x4 y squared y 5, derivative of 4x dx. So that is it. Now the next step said use the derivative to multiply each term one by one. So this one, so I have d of x raised to the power 3 dx plus d of x4 y squared dx plus d of y5 dx equal to the same derivative of what? 4x. That is already there for me, so there is no need. The next step says we should differentiate each term one by one. But look through the function very well. We have a product function here. Two functions are multiplying. We need to break it down using product rule. Then from there, we will now apply the differentiation to each term. So using product rule, you can you break this down so that it will be easier for you to differentiate. So I'll repeat the remaining steps. D of x raised to the power 3 dx plus, now for product rule, hold the first function. You can also hold the second function. Since multiplication is commutative, so you decide on which one you want to hold first. I can use the first one, I can use the second one, I'll still get the same result. So I will hold the first function, x raised to the power 4, differentiate the second function, d of y squared dx, plus hold the next function, which is y squared, differentiate the first function, dx4 dx. So you get it. A simple understanding. What this means is that I'll hold the first function, use d ds to multiply the second function. That is what I have done. Plus hold the next function, use d ds to multiply the first function. That's what I have done. If you turn it by holding this one first, it will still be the same. You'll get the same result. So we have plus this derivative of y5 and then equal to the derivative of 4x dx. So that is it. Now we can now differentiate each term one by one. since I've now broken down this, it has become simple for me to solve. So let's differentiate each term. We are differentiating x to power 3. So we use the basic rule that says that if I have x raised to the power n, then when I differentiate something like this, I am getting nx n minus 1. So you just use the n to multiply, you subtract 1 from the n, which is your power. So if I have x raised to the power 2, then the derivative of this, differential of this, will give me 2x2 minus 1, giving me 2x. If this variable is y, you repeat the same steps. So let's do that. So now when I differentiate this, I am getting 3x squared. But in implicit differentiation, there is one thing that we should know. Whatever variable you differentiate, you have to indicate it because it's a function of a function. I don't want to move into details, otherwise I'll be talking too much. So I differentiated x with respect to dx. So I will introduce it, or I will show it. I differentiated x with respect to what? X. So dx. I differentiated this x with respect to this one. So dx. Plus, now I have x raised to the power 4. I am differentiating y squared. So when I differentiate that, let me put it here. This will multiply. I have 2y. 2 minus 1 will give us 2y. I differentiated y with respect to dx. So I will indicate my dy dx plus y squared. I'm about to differentiate x. So times 4x 3 dx. I differentiated x with respect to dx. Then plus, I'm differentiating y 5. So 5y to power 4 dy dx, giving me differential of what? 4x will give me what? 4. So 1 times 4, 1 minus 1, x to power 0. Anything to power 0 is 1. And then I differentiated x with respect to dx. So dx. We note that every term which is having ds will cancel, giving us 1. So once you understand this, you don't need to indicate this ds, you just forget about it. So now every step we have here is 1. So let me show it so that you understand what I am doing. So I have 3x squared, ds will cancel. I have 1 plus, I have 2 multiplying the whole function, so 2x4 y dy ds. I cannot cancel dy and ds, they are not the same. So plus, there's 4 here, so 4, let me write the x term first, 3y squared. Dx here will cancel, we have 1. Then plus 5y 4 dy dx, giving me 4 dx, giving us 1. That is it. Then the last term said that we should group all terms having dy dx to one side, then we add the rest and we equate the function to 0. So I'll write this one first. I have 2x raised to the power 4 y dy dx. Then this term also has dy dx, plus 5y raised to the power 4 dy dx. The remaining terms we can write it. I will start with this one, plus 3x squared times 1 will give us 3x squared, plus this term plus 4x cubed y squared. Then there is 4 here. I'll carry this 4 to this side, making it minus 4 equal to 0. So now I've equated the function to 0. Then the step said that factorize the dy dx out. So let's factorize the dy dx. So when I factorize dy dx out, I'll be left with 2x 4y. So I have 2x raised to the power 4y plus, I'll factorize dy dx out here. I have 5y raised to the power 4. I'll put everything into bracket, dy dx. Now don't bring the dy dx here. Let's assume that everything here is the coefficients of the derivative term. So don't bring the dy dx here. Don't put the dy dx in front of the word bracket. Rather put it at the back of the bracket. So when I give you a function, it is, let's say, 2 dy ds, 3 dy, or x squared dy. We don't write dy ds into x for making the word tautology. So this part, there is nothing you can do about it again. So you repeat it, 3x squared plus 4x cubed y squared minus 4 equal to 0. And this is your final answer. So this is how you differentiate an implicit function. Apply derivative to the function. Use the derivative to multiply each term. Check if there is a product function. If yes, break it down. Now differentiate each term. Remember, every time that you differentiate, you indicate it. If it is x, you differentiated, you indicate ds dx. If it is y, you differentiated, you indicate dy dx. Else everything you do is wrong. Then you do that, after which you group all like terms for dy dx. That is what I have done. Carry all functions that do not have dy dx to the back of the test dy dx functions. You create the result to 0. Factorize the dy dx out, and you are done. So this is it. Thank you very much for joining me here on the Twitter Think channel. If this video has been helpful, kindly subscribe to my channel for more updates. My name is Daniel. I'll meet you in my next video. I'll take more examples under this topic. See ya.